Hello and welcome. This is our sixth lecture video in series of deep learning. I hope that you have been through last five lectures. We are covering theory and concepts in detail with mathematical approach. In last lecture, we understood the concepts of vanishing gradient. And in this particular lecture, we will go through various activation functions and which of them are used popularly. So we will go through different functions here and see certain important functions as well. One problem that we face during this back propagation is important to understand. As we perform the back propagation to update the weights and biases of all layers starting from the last layer till the initial layer. We saw one example of backward propagation in our last video lecture number 5. Consider the last example and you can see that the derivation of error E with respect to the weight W2 and W1 are reducing and very small. It is 0.05706 and 0.001021 respectively. This is very marginal. Hence, the learning rate is marginal and hence the number of iterations will be very high. Due to this, for each backward propagation, the upgradation rate is very small. As we use sigmoid function at every layer to obtain the activation value, which use as input to the next layer, and since the sigmoid always produce the value between 0 and 1, hence during back propagation at every step using the learning rate, the upgradation value produced is very small in decimals, and this value keeps decreasing as we progress towards the initial layers from output layer in back propagation. Due to this, progress in upgrading the weights and biases are too slow and need more and more iterations. This problem is known as vanishing gradient descent problem. Now, how to achieve better performance to upgrade weights and biases? To address this vanishing gradient descent problem, we use activation functions. In coming slide, we will discuss about the activation function. Till now, we were using sigmoid function and we also saw the drawback of using sigmoid function. We talk about some more useful and productive activation functions which can replace the sigmoid function. Now, these certain important functions are listed over here. We have 7 types of activation functions which can be used to build a neural network. These 7 types of functions are namely binary step function, linear function, sigmoid function, then hyperbolic tangent function, then rectified linear unit, which is popularly named as ReLU function, and leaky ReLU function, which is a modification version of ReLU function. And finally, the 7th one is a Softmax function. We will discuss about 4 important and most widely used functions over here. So out of these 7 functions, activation function, we will discuss about these 4 important activation functions in this particular lecture. We will discuss about sigmoid function, hyperbolic tangent function, rectified linear unit or ReLU function, and Softmax function. Let us talk about sigmoid function first, which we are using till now. Look at the curve here, which represents sigmoid function. It shows relationship among the activation A and computed sum Z. The curve shows that when Z is 0, the value of A is 0.5, and when the value of Z is large positive, value of A is close to 1. When the Z is very large negative, the value of A is minus 1. Sigmoid function is normally used at hidden layer of the neural network. But if you notice that the function is very flat for value of z beyond -3 and above 3. Hence, once the function falls in this region, the gradient will be very small and near to 0. Due to this, although we apply backpropagation with intention to make the network learn at hidden layer, the learning rate will be very small, almost minute and dense. So, hence, the network will not learn. This is problem of vanishing gradient problem. Another drawback with the sigmoid function is that the value is always between 0 and 1. That means the value we receive are always positive, and hence the value passed on to the next layer will be of same sign. In certain cases, we don't desire to have only positive values. So here exists the need of scaling the sigmoid function. We have hyperbolic tangent function here, which is scaled version of sigmoid function. As a result, it brings the hyperbolic tangent or tanh function. It is very identical to sigmoid function. The difference among the sigmoid and hyperbolic tangent function is that the sigmoid function is symmetric with respect to 0.5. Hence, the value range we obtain is 0 and 1. However, the hyperbolic function is symmetric about origin and range is between -1 and +1. However, it does not eliminate the vanishing gradient problem in every case of deep neural network. So for this purpose, we look forward for another function. You can see the activation A is equal to exponential of z minus exponential of minus z divided by exponential of z plus exponential of minus z in case of hyperbolic tangent function. Let us go ahead and look for another function. The next one is one of the most popular activation function. It is called Rectified Linear Unit function and popularly known as ReLU function. It is used in place of sigmoid function in almost all designed neural network as activation function in hidden layers. ReLU function is non-linear function which does not activate every neuron at same time. In case of ReLU function, if the input is negative, it is converted to 0 and the neuron will not be activated. Hence, some of the neurons will not be activated, and due to this, it is possible to make the network sparse and efficient. Apart from this, ReLU function also overcomes the vanishing gradient problem. Because of this, the ReLU function is widely used as activation function at hidden layer level. Now, we will go through one more activation function, and this particular function is named as Softmax Function. The last activation function which we will discuss now will be Softmax Function. It is modified version of sigmoid function. You can look at the formula of Softmax Function where activation AI is equal to exponential raised to power zi and divided by summation of e to power zk, where k is equal to range from 1 to m. It is widely used when we are working on classification problem. This software function is normally used as output layer when the problem is pertaining to classification. Let us take an example. If the network is having 3 neurons at output layer and having the computer output layer value as shown here, then by using the softmax activation, the output converted to value between 0 and 1. We can classify it and determine its category. This way, it is easier for us to classify a given data point and determine to which category it belongs to. As a summary, finally, we will just summarize this lecture. Sigmoid and hyperbolic functions are hardly used at hidden layers due to the vanishing gradient descent problem. ReLU function is widely used at hidden layer. It is used at hidden layers only and for output layer based on the problem. When we are building the model, we can begin with ReLU function at hidden layer, and in case the ReLU function does not perform properly, other functions may be used. If a problem is of classification, Softmax function is used at output layer. With this concluding note and summary, I sign off for this lecture. Hope you understand the concepts of vanishing gradient descent and about various functions which we use as hidden layers and output layers. These functions are known as activation functions. In next lecture, we will talk about convolution neural network, popularly called CNN, and Keras libraries. Learn, share, and grow. Have a great day. Thank you.